systems and machines have their own limited service life. It has always been the goal to improve the maintenance efficiency of any technological asset. The efficiency is improved when we use less time on downtime, reduce the maintenance efforts, and thus reduce the impact on our environment. Too many fatal accidents have occurred where there should have been none. The crash of a DC-10 aircraft in Sioux City. The helicopter crash in Peterhead, Scotland. The collapse of the Alexander Kielland oil platform in the North Sea. The crash of the Super Puma helicopter in Turøy, close to Bergen in Norway, are all but a few of the many unnecessary incidents. Several hundred people have died in these accidents. So what is the source of these failures? Investigations have shown that these fatal accidents were due to material fatigue. So why could not smart engineers have prohibited these failures? Material fatigue is due to repetitive stresses in the material. These stresses, when repeated many thousands or millions of times, does not need to be above the material yielding or fracture limit to cause collapse. Dinova has developed a process that will prevent such accidents in the future. The process, FatigueMap, will take the steps beyond the normally used process of designing the structure to withstand the expected loads in a given environment. FatigueMap will monitor the real stresses and thus foresee when the next maintenance is necessary, before a catastrophic failure occurs. The process has been tested on a land-based windmill and the results are very uplifting. In this way, a proof of concept has been established. The steps in the process are: establish a digital twin of the asset, in this case, a windmill. The digital twin is a finite element model. With the finite element model, identify important stress areas. Instrument the important stress area with strain gauges. Link the results from the instrumentation to the digital twin. The digital twin, together with the monitored data, will follow the asset over time. Link the digital twin to a fatigue calculator with input from material fatigue properties and accumulated number of cycles. FatigueMap establishes a continuous link between the monitored data and the digital twin by means of big data and Internet of Things. Continuously calculating the remaining fatigue life. Several locations are instrumented, both locations with high stresses, red areas, but also locations with low stresses to verify the results. The sensors were mounted with correct locations to correlate with the results from the digital twin. The logging equipment with computer, battery, and amplifier were attached to one of the windmill wings. With everything mounted, we are ready for measuring. The measuring results have to give information about windmill rotational speed and wind velocity and direction. The measured results and the information from the digital twin will give an exact picture of the fatigue life of the system. The process has been tested on a land-based windmill, but the concept can be used on any dynamic system subjected to fatigue damage. Applying the fatigue map on any system subjected to fatigue loading will help you get a look into the future. 2. Prevent fatal accidents. Reduce unnecessary loads on the environments. Reduce the number of unplanned maintenance stops. Reduce maintenance time and costs. Reduce environmental footprint. And thus, from this information, you can learn to select the best material for the system, optimize systems design, change design philosophy, save time and money, and above all, save lives. Using FatigueMap will give full control before accidents happen.